Hey, Ibrahim. How are you? Not bad. What exam do you have? Do you have an exam tomorrow? Oh, calculus. Don't forget the vectors portion too. Lots of derivatives to take for you tomorrow. Okay, hopefully they were helpful. I made those a couple of years ago, but I think I have calculus next year, so I'll have to make some new ones. Oh, thank you. If only you would have known. I'm sure the calculus exam won't be too bad. I don't know if I haven't seen it this year's one, but the previous years were fine, nothing crazy. All right, my grade 10s, if you're there, you can ask away. I've got the worksheets loaded here. We can start off with our quadratics, whatever you guys want to go through here. You guys have your exam tomorrow. I'm ready to help you. Hey, Dia. How are you? You have calc as well tomorrow? Dia. Oh, Tuesday. Oh, okay. I bet you grade 12s are excited to be done. No more high school. Hello, Dima. You got questions for me, Dima? I can start to go through 'em. What do you need? I am ready. Sure. Dima, you want quadratics page 2, part 2, sure. Do you, like Marie, you want 1A from quadratics part 2? Or do you want 1A from quadratics part 1? Oh, part 1, sure. Okay, and then Dima, just let me know what part of quadratics part 2 you'd like. But Marie, for something like this, if we're doing this one here, you'll see this on the exam. I'll give you some questions, probably in the written response, that just say expand and simplify. And that's all I want you to do. So you're going to distribute, like with something like this first one. Actually, I can zoom in on this. With something like this first one, you're going to go ahead and distribute this monomial into the binomial. So when you do that, you multiply the coefficients together, so the number is 4 times 2 is 8. And in this case here, you have u to the power of 3 times u to the power of 2. So in this case here, that's u to the power of 5. Again, remember when you multiply with the same base, your exponent laws from grade 9, you add the exponents, 3 plus 2 is 5. And then this becomes 20u to the power of 4. And the reason for that, in case you've forgotten, this is 5u. If they don't write the exponent implicitly, it means power of 1. Is that okay, Marie? That's how you do these expanding and simplifying questions. Mohammed's asking me for trig. Yes, and thank you. For trig, all we need to know is cosine law, sine law, right triangles, word problems, angles, lengths, right angles, similar triangles. Yeah, I mean, that's the whole unit. Like, you might need to know, like, you know how we did the questions. I don't know. I feel like the trig section is right. It's posted for you guys under the announcements. You have a trig worksheet. Looking like this here. So I kind of outlined all the trig stuff you need to know. It's all on this worksheet here. Should cover everything. You can review the old tests and that sort of thing as well. You should be fine. Dima, you asked for part 3. I don't think there's a quadratics part 3. Oh, there is a quadratics part 3. Okay, and which part do you want from part 3? If you are looking at, Dima's not answering, so it's taking too long. So let's go ahead and, if I did do 1 here, some of the concepts from 1 that you'll see definitely on the exam is, you know, given a quadratic, something like this, be able to identify everything in that you see. So for instance, visually I can see this quadratic has roots at 1 and 5. So I know the quadratic here has roots or x-intercepts at 1 and 5. I know my vertex is sitting right here, and that's going to be equal to 1, 2, 3 over and 1, 2 up. So that's 3, 2 is your vertex of the quadratic. I can see this quadratic hits a maximum value, hits a max value. If they ask you, if they use the word optimal value, if you see this on the exam, optimal value, that's referring to your y coordinate of your vertex. So in this case here, this is the optimal value would be 2. Right? So like from the graph, you can quickly find all these things. Dima is talking about the stuff. I'm assuming you mean all these things here. So you've got your roots. I've got my vertex. It hits a maximum. I can quickly see the y-intercept is sitting right here. This is approximately 2.5. So the y-intercept is 2.5. So I know this has a y-intercept of 2.5. They also ask you, like, based on the graph, to find the equation of the quadratic. Like, what is the actual equation of the quadratic? We sort of talked about this. I had asked you to do it under, like, I referenced some textbook questions to try, but we kind of have this here. Like, they want you to find the equation of the quadratic. I'll put that instead. That has roots at 1 and 5, and it passes through the point 3, 2. Don't forget your vertex is just a point as well. So like with this here, if I wanted to find the equation of the quadratic that has these characteristics, I know in factor form, I'd have a root at 1 and a root at 5. Right, so using factor form, I know it looks like this. Oops. And furthermore, I know the quadratic passes through the point 3 and 2, so I can sub that into my quadratic. I can get rid of the y and change it to a 3. Get rid of the x and change it to a 1, and I can solve for a. So this becomes, what, 2 times negative 2. So I end up getting a here is negative 1/2. If you actually do your math, you get minus 1/2 for a. So the equation is minus 1/2, x minus 1, x minus 5 for this. Sir, if I know the distance in midpoint formulas, I lose a mark for what? Will I lose a mark for centers of triangles unit? I think what you're trying to ask me is there anything other than the centers of in the centers of triangle unit? Is there anything other than distance and midpoint formula that arrive on the test? And the answer is yes. Oh yeah. There's other concepts definitely being asked from that. You're gonna, the multiple choice questions I outlined in Unit 2, that kind of covers everything that you need to know, in addition to the questions. So whatever I put on the worksheet, I tried to cover everything that will pop up. So everything here and here. If you know all of that, then you're good for the exam, for my exam. If you're talking about key points, I would just know this whole worksheet. So all of this stuff from numbers 1 all the way down to the multiple choice. These multiple choice questions were pulled from your online test you guys had. So these are from the online test that you had, and I knocked it down from 26 to 11. And those cover like everything that you need to know. But you have the mark breakdown, so you know how many marks come from centers of triangles approximately from the exam. Like I said, the bulk of the exam is quadratics and trig, but you're still going to see stuff from the other sections. Okay, Dima, you're not saying much regarding this question. Did you want me to do another one? Do you want me to, like, where do you guys want me to start with this stuff? Quadratics, trig, what do you guys need here? Oh, good, Jima. Anything else I can help you guys with? Sure. Here we are. 1 to a bazillion here. We can go through any one of these. Do you want me just to pick some of these at random, or are there specific ones? Can you do the 3 textbook questions? You'd have to quote the page and the number Do I have the page and the number? Okay, I'll pick up some of these. Let's try C, K, F, and N. Pick randomly, sure. All right, let's look at C. So this question here, and you'll see this on the exam, find the roots by factoring. You're going to be required to factor, right? You can't just go to the quadratic equation. You have to go ahead and factor this. So whenever you're looking to factor something, the first thing you want to always look for is a GCF. If I take a look at 1C, I am not seeing a GCF on this, right? There's not a common factor going on between the 16 and the 9. So in this case here, I can go right to difference of squares. So I can re-express this as 4u quantity squared minus 3 squared, right? And by doing that, now I can apply my difference of squares formula. So now I have the product of two expressions is 0. Either, I mean, the only option is one of these has to be 0 to make this happen. So that's kind of where we go from here. It must be the case that 4u minus 3 is 0, or 4u plus 3 is 0, which means u is 3/4, or u is minus 3/4. That is it. Those are our two options. Okay, so that would be, one example of finding the roots by factoring. I then just randomly picked K. Again, with these questions, you first want to look for GCF. And you'll notice that this question here that I'm highlighting in orange has a GCF of M. So if I factor that out, I'm left with 4m plus 7 equals 0. But now this is factored, right? I have the product of two expressions. Either m is 0 or 4m plus 7 is 0. And those are your two options. So either m is 0 or 4m plus 7 is 0, in which case m is minus 7 over 4. So this one here, these are our two answers for this one. Thanks, Mohammed. Okay, there's K. I can go through these two here, Dima. Same idea, right? You're looking at this here. I'm looking for a GCF on this. That's going to be an x. So factor out an x, I get 7x minus 12 is 0. So just two options. Either x is 0 or 7x minus 12 is 0. So this is what, 12 over 7? Or 0? Right? This one's a little more interesting just because it's a little more difficult. But this has a GCF of x squared this time, this one. So I'm left with x squared minus 10 inside. Right? Because I can actually factor out a x squared out of this. So therefore, either x squared is 0 or 3x squared minus 10 is 0. And you've kind of got to solve both of these. But that's the same thing as just saying x is 0. Right? You could take the square root of both sides if you like. And then for this one here, 3x minus 10 is 0. You can just solve for x squared if you want. Right? Bring the 10 over. Divide by 3. And then take the square root. You'll get this value. Is that all right? Yeah, just leave it like that. You don't have to do more. It would be fine. Okay, I'm going to take a look at the textbook questions Mohammed had asked here. We've got page 328, 329, number 7 and 9, and then 418, number 2. So for 7, they're all kind of the same. You guys can look at 7b yourself. Like, roughly what's going on is they... Hello, Jasmine. Roughly what's going on is they give you a quadratic for 7b. And you kind of got to read it off the graph. But, Mohammed, I don't know if you got your textbook there on you. But if you can see on the graph, they give you these 2 points. And you can kind of tell, sure thing, you can kind of tell that every box is worth 20. So if you look at this here, this is the point 20, 0. And if you look at this point here, this is the point 60, 0. And if you look here, this is the point 40 and 100. You kind of have to read that off the graph, every box being 20. On the exam, I'll make it much more clear. You won't, it'll be very clear what the points are. But based on the scaling for 7b, this is 7b, those are like the key points. Those are my roots, and I have my vertex. So if I want to find the equation of this one, you'd go y equals a. Because I have my roots here at 20 and 60, I can write this as x minus 20 and then x minus 60. And then what I can do here is I can sub the point in. So I can sub that point in and solve for a. So in this case here, y equals 100 and a equals 40. So I get 100 equals negative 400a. And solving for a, get a is negative 1/4. Mohammed, are you following this one? So the answer for 7b, it's just like the one I had done, is minus 1/4. If I interpreted the boxes correctly that they've drawn, that's my answer for this one. Good, Mohammed. Oh, that's good. That's good. Hiya, Jasmine, and Miriam. Study, study. Okay, well, Hi is good at the quadratic word problems. So you can kind of have Hiya set you up with that. I'll do some word problems as well. All right, after you're done this, can you look at... Yes, for sure. Okay, there's 7b. Mohammed, you wanted something from 9 as well. While I have the textbook open, I'll show you guys 9. There's no specific one. They're all about the same. But let me take a look at like 9b. So for 9b, we have zeros. Oh, yes, yes, Jasmine. 9b, we have zeros at minus 3 and 7. And they say in the question that there's an optimal value at 4. So I have roots at minus 3 and 7, optimal value at 4, and they want me to find the equation of the quadratic. So if we were to find the equation of this quadratic here, you go right to factored form. So do you see, by doing this, I've now created a quadratic that has a root at minus 3, and then it has another root at 7. right? Is everyone okay with that? Like, I needed zeros at -3 and 7. I've made that happen. The only thing is I don't know the a value. So they tell me I have an optimal. This is a bit tricky. They tell me I have an optimal value at 4. Does everyone remember what they referring to as optimal value? I said it earlier today. We said it in class as well. Do you guys know what this is referring to? Optimal value refers to what? From my vertex, we have these two letters. Which letter does it refer to? My k value. Does anyone know how I can find my h value? Well, my h value is my axis of symmetry. So they gave me zeros at -3 and 7. And if my h value represents my axis of symmetry, I know that my h value here, I can add up my roots and divide by 2. So my h value is a 2. So therefore, the vertex of this quadratic is really 2 and 4, because they use the word optimal value. And you might see this on the exam tomorrow, but that's just your k value. And then by adding up the roots and dividing by 2, I get my h value. So now I have the vertex, but that's also a point. So I can sub that into here. I can get rid of the, and go down here. And let me make this a little more clear. I can now go down here and I can get rid of the, I can let this be my x and this be my y and sub it in. So I have y is 4. And then x is 2. So this becomes 2 plus 3. 2 minus 7. Right? And then I can go ahead and solve for a. Right? You'll see here 5 times -5 is -25. And solving for a, I get a is -4 over 25. Right? So putting this all together, if I were to answer 9b, the answer is y is -4 over 25, x plus 3 times x minus 7. Mohammed, we good? Yuppers. Okay. Okay, well anyways, there's some questions from 7 and 9. 418, Mohammed, 418, number 2. You know what, 418 number 2, let me quickly show you that, and then I'll do some quadratic word problems and Demas questions as well. Just to, because it is a little bit different. In 4a, for instance, they give you the vertex is 0, 7, and they tell you pass through the point -2, -3, and they want you to find the equation of the quadratic. So if you were to answer 418 number 2a, this time they gave me the vertex directly in a point. So I'm not going to go to, I don't know the roots, so I'm not going to go to factor form. I'm going to go to vertex form. So you should know this for tomorrow's exam, but that's vertex form. So I'm going to dump that in vertex form. This becomes x minus 0 squared plus 7. Right, if I put this in vertex form, right, because I know my vertex, I substituted the h and k values. Now I need to find the a value once again. I can substitute the point in now and solve for a. So this becomes, you can see, you can quickly solve for a, subtracting 7 on both sides and Squaring negative 2 is 4. And a is negative 10 over 4, which is negative 5 halves. So the a value here is negative 5 halves. X minus 0 squared plus 7. Sure. Okay, there's 418. Mohammed was asking that one. Okay, Jasmine wants question 7, quadratics, sheet 2. Sure. You know what, Jasmine? I had said this to some other people as well. We can change it to have it say exactly one root. And to have exactly one root, you have to calculate your discriminant. Remember, like, there's 3 options. There's 3 options here from the discriminant. You can do b squared. So it's like b squared minus 4ac. Now, if you remember, Jasmine and everyone else, there's 3 sort of steps here. If my discriminant is equal to 0, we have exactly one root. If the discriminant is greater than 0, you have 2 real roots. And if the discriminant is less than 0, you have no real roots. So of these 3 options, I've got the discriminants equal to 0, so it's exactly one root. So if I go ahead and calculate this, the discriminant is 64 minus 16k for this question. And since Jasmine was asking this, you're going to set the discriminant equal to 0 because I changed it. I had a different phrase in the other question, but I think it's a little bit too difficult. Let's just keep it at exactly one root is fine for the exam. So you set the discriminant equal to 0, and you actually solve for k here. Right, so you can bring the 64 over and divide negative 64 divided by negative 6. And if you do that, you get here... that'll come out to 64 over 6. I can cut that in half, so 32 over 3. And that's it. I think that's in lowest terms. Is that okay, Jasmine? Dima, what did you need again? You had asked a question. Oh, Dima, after you're done this, can you look at quadratics 3, question 2? Yes. So for these here, there's nothing really, it's just a little sketch. So I really just want you guys to identify it's 16. Oh, I copied it wrong. I put a 16 and then a 6. I forgot to write the 1 down. I see. Okay. So that'll be a 1. That'll be a 1. That'll be a 1. That is not going to be... This will be a 1 here. Oh, that comes out nicer. It comes out to be 4, yeah? 4 times 16 is 40 plus 24 is 64. That works out nicer. How it is 6. It's a 4. I just forgot to carry the 1 down here between these two. Okay, so answer's 4. Very good. Dima was asking... Oh no, where's Dima? There's Dima. Question 2. So for question 2 here, I really just want you guys to find the vertex of these ones here. Let's actually find the vertex for each one of these. This vertex is -2 and -8. This vertex is 0 and -8. This vertex is 2 and 1. No, oh no, I'm just joking. And this vertex here is -1 and 0. So Dima was asking a good question, just like, what's the deal with these sketches? It's just a sketch, so the only thing I'm really interested in on the exam is that you can get you identify the vertex properly, you know the direction of opening properly, and you can do a sketch and have everything in the correct quadrants. So for instance here, this vertex is 2 and 1, so it's like somewhere here for this one. It opens downwards. You can quickly check the y-intercept, right? We did this in class. Sunday. Do I have to? You probably don't need one after this, yeah? Probably be all set. So if I check, I'm getting the y-intercept here is 0, is that correct? So in terms of a sketch, like usually we kind of lead up to a bit more questions here. Like you maybe have some lead up questions. They ask you to find the roots, that sort of thing. But this would be a rough sketch as to what they're looking for. It would be, the sketching would be more closer to what we did in class, where I ask you for the y-intercepts, the roots, vertex, and then you can do like a proper sketch trying to hit all those characteristics on your graph. But that's all they're looking for quadratics, part 2. Anything else I can go through? You ready for this? Sure. Did I list any here? Here's 2 quadratics. We can do these since they're just sitting here. I do not know. At least one. I would say at least 2. Or at least 2 that like require a quadratic type problem. Let's take a look at number 5 here. So the height of a soccer ball is measured in seconds given by the following. So negative t squared plus 10t. So this is the height of a soccer ball in meters to the ground. How soon until the ball reaches 1 meter? Okay. So we can talk about a bunch of stuff with this, like this word problem. We can go beyond what the question is asking. So first of all, like if I were to sketch this quadratic, it would look nothing like that. It would look something like this. If I were to go ahead and sketch this quadratic, if you take a look, the reason I know it hits the ground is because if I let time be 0 and I see what I get, I end up getting h is 0. So I know that right away that this ball, soccer ball that's being hit, it's leaving from the ground. It travels until it hits a max distance and then opens and then hits the ground again. The reason I know it opens downwards is because the leading coefficient is negative. So I know the quadratic opens downwards, and I know therefore it hits this maximum value. Now the question is not asking all this information. The only thing the question wants to know is how soon does the ball reach 1 meter? So like, if I let h equal 1, you would have a horizontal line illustrated in my diagram here. And I want to know, when does that happen? So you just want to find these 2 points. In fact, you don't want the 2 points, you want the first point. You want to know, when does it hit 1 meter right on? When does that happen? Because that's what the question's asking. So you just set your height equal to 1 and solve this quadratic. So if I set height equal to 1, the word problems are like the ones assigned in the worksheets and the textbook questions. So if you go through the worksheets and textbook questions, that'll cover that sort of concept. So if I bring everything to one side, I have my quadratic, and then I go like this. Then I can go ahead and solve this here. Right? So notice I set this equal to 1 because I want to know, at what height is it 1. Brought it to one side and multiplied across by a minus sign. I have the following. Then I'm going to go right to the quadratic equation to solve this. So the quadratic equation is, and again, you'll need to know that for the exam, it's negative b plus or minus a square root of b squared minus 4ac, the whole thing over 2 times a. Right, so I went right to my quadratic equation, so I'm getting 10 plus or minus. This will be 100 minus 20 is 80 over 10. And then you got to solve this. Don't forget tomorrow to bring your textbooks to class. You know who you are, who did not give them to me already. And don't forget to bring your calculator to class, because I cannot give you mine. I get 1.89 seconds. And then 0. So I'm getting, for my next one, I'm getting 0.11 seconds about for these here. So I'm getting 1.89 seconds and 0.11 seconds. So this happens at 2 times when time is 0.11 seconds and time is 0.89 seconds, or not 0.89 seconds. Okay, so from this here, the question is asking, when does it first reach 1 meter? So the answer would actually be just this one. It'd be the 0.11 seconds. That would be your answer for this one. It would equal 0.11 seconds exactly. Now, in the past, we've done questions like, I've asked questions like, how long is the ball above 1 meter? If you guys remember when we did that, we would subtract these 2 times together. That's not what they're asking in this question, but they're asking when does it initially hit 1 meter. So that's at 0.11 seconds. When would you use the quadratic formula? You'd use the, for this question, Jasmine, I would use the quadratic formula if I'm ever having to solve a quadratic. I would go right to the quadratic. I wouldn't even bother to try to factor it. If it's a word problem and like you want to find time in this case, I would just go right to the quadratic, because chances are it'll be messy. You don't want to do that on every question on the exam, especially the ones that say solve by factoring, right? Because you'll get no marks for that. Like find the roots by factoring. You cannot go right to the quadratic equation every time. Plus you'll run out of time on the exam if you do that. But for the word problems, I would go right to the quadratic if you need it. Like if you're looking to solve a quadratic. It's not always the case. Like some questions you get a quadratic, it's already in vertex form. I don't know any word problems I had assigned. Are there any that I had assigned from the textbook that I need to go through? I don't recall. But here's a quadratic word problem. There's also a fencing one here, right? I think I had a fencing one right here. Here's another quadratic word problem type. Let's take a look at it. So for this question here, Randy is building a fence at the side of the warehouse. He has 120 meters of fencing and plans to use the side of the warehouse as one side of the rectangular fenced area. What dimensions of the maximum area can Randy enclose? Yes, Marie, of course. Yep. Except for the multiple choice. The multiple choice will just, there's no part marks for multiple choice. So this question here, you've got this guy Randy building a fence, the side of the warehouse. So he's using one of the sides. So it's kind of like what we already talked about. But with this question here, these are x's and these are y. This is going to be my y for this question. And I know the perimeter of this is going to be 2x plus y. So they tell me in the question that I have 120 meters of fencing to work through. So this is 120 is 2x plus y. Is this okay? Now in this question, I want to maximize. I am doing the fencing one. Did you do the fencing one? That's the real question we need to be asking. So I want to maximize area here, which is x times y. You can't maximize two variables. You can only maximize one. So what I've done here is I've related the perimeter to the x and y variables. So then I can isolate for y and express y as 120 minus 2x. So therefore I have these, I want to maximize this variable, but I can't do it with 2. But I can get rid of the y and change it to 120 minus 2x. And then I can go ahead and solve this. Right? Because now I know this is a quadratic. I know it opens downwards. I know one root is 0. That's going to be right there. This right here is my second root, so I can set this equal to 0, in which case I get x is 60. So maximum area happens right in the middle when x is 30. So that's where max area happens. Max area happens when x equals 30. Is everyone okay with that, with this fencing question? Right, so what did I do? It was a 3-sided fence, so I only had 3 sides. I know these opposite ones are x's each because it's a rectangle, and that's why. I have my perimeter formula, which is 2x plus y. I have 120 meters of fencing to work with. I want to maximize the area, which is x times y, right? X times y, that's what I want to maximize. You can't maximize 2 variables, you can only maximize 1. So I use my perimeter relationship to rewrite the y as x, and now we're here. Now that I've done that, I can go ahead and solve for this. I have the endpoints 0 and 60. The axis of symmetry is the middle. That's where maximum happens. So max happens at the middle, so I add up the roots and divide it by 2. I got my middle, my axis of symmetry, which is also the x, like the maximum value. So if I let x equal 30, here, this point is like x is 30, and this would be your area at 30, which they don't ask you to calculate it, but we can calculate it here. This is 30 times 60, and area is 1800. 1800. So for this question here, the max area is 1800 square meters, and the dimensions of this are going to be 30 in the x. By your y value, you can sub it back in, to which you get 60. So this is 30 times 60. So there's a fencing one. Be able to answer the fencing questions. I'm sure you'll see some fencing word problem on the exam. And there's different like permutations of this. Like we had versions where like you split it down the middle and there's two rectangles, or with a side missing, or you can have a situation where we sort of looked at it where it's like this, and you'd have this perimeter. This would be x, 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 and then I could let this whole thing be y. And y, we have that. You could, you know, have it like this. There's so many different variations on this question here, right? And you only have one side. You could have a fence that looks like this, but it's all the same process. Nothing really changes. Your perimeter formula is different, but this would be x and y. Right, your perimeter formulas would be different, but the process is exactly the same for the fencing questions. Can I do one of the quadratic questions part 2, part 3? Sure. You know, Lena, the only thing I'm really looking for here is let's grab one of these. Like, let's take a look at this one. The only thing I'm looking for with something like this is, you know, if I gave you this and the question said sketch, right? I'd want you to say, okay, well, this isn't, I can write this as vertex form, for instance. So I know the vertex of this quadratic is 0, -8. So I know it starts somewhere down here at 0, -8, and I know that it opens upwards. So I know it's going to look something like this. The one below it. Oh, sorry. I didn't know I double worded this. Yeah, sure. Is there a specific one you want, or just any one of these? I guess D, maybe? Sure. So for D here, they ask they find the max minimum value of, and the value of x that occurs when expressed in quadratic form. Okay. They're essentially asking you here, Lena, for the vertex. So if you have a quadratic in standard form, and I want to go ahead and find the vertex, what you need to do here is to find the vertex, your h value is going to be -b over 2a. So in this case, -12 over 2 times -2 is 3. So my h value comes out to be 3 for this one here. So to find your k value, we kind of talked about this in class today, I believe. You're going to sub it in. Right, 12 times 3. So I'm getting, like, I did the negative b over 2a thing to get my h value. So I went ahead and did my math. I got 3. I then subbed it into my quadratic to find the y, which is 7. So I know this quadratic has a vertex of 3 and 7. So I have a vertex of 3 and 7, and I know the a value is minus 2. So then y equals negative 2, x minus 3 squared plus 7. Right? Because it's the same a value. And that's it. Now they use different terminology. They say, what's the max value? So you'd say, okay, because this opens, like Lena, because this quadratic opens downwards, right? It hits a max. So the max value, like we had discussed, is your y coordinate. So it hits a max value of 7. And then the x value that this happens at is 3. They're just asking you for your vertex. That's all they're asking you for. But it's just worded a bit differently. Can I do, sir, can you do question h quadratic 2? Sure. Okay, Lena, there's D. Factoring. Right, this right here, Dima. Sure. Okay, so for this one here, they want you to find the roots by factoring. So looking at it here, I see a simple trinomial. Right away, I think of product sum. Well, my product is 20, and the sum is negative 12. So I have to think of two numbers that multiply to be 20 and add to be negative 12 here. You can start to go through all the permutations. But I'm thinking negative 10 and negative 2 will do it. Because if I take negative 10 times negative 2, you get 20. And if I add them, I get negative 12. So therefore, this will factor into x minus 10 times x minus 2 equals 0. So we've got your two answers. One root is 10, and the other root is 2. And that is it. Is that okay? No problem. Yeah, don't forget about that, Dima, on the test. Like factoring using product sum. Because that'll be there too. Like hopefully that's covered here. There's more factoring. I think I assigned in the textbooks as well. But hopefully you can cover all those questions. Yeah, good. Is there anything else? So like in terms of what you have to know here, remember to do your difference of squares on the exam. Remember product sum questions. And you can review old videos or your old lessons. Remember charting, or that's the only thing I had taught, charting. And that's all combined with GCF is always a part of it. But those are like the three sort of factoring techniques that we've talked about, is either GCF, well, difference of squares, product sum, charting, or sometimes GCF just on its own, which we saw in some of the examples I had done, or like GCF and then charting, or then difference of squares, or then product sum. those are kind of the options that exist. And you see it here in number 2, right? Number 2 here, I see this is difference of squares, this is charting, this is product sum, and then probably a difference of squares, product sum, difference of squares, charting, product sum. This will be GCF, and then charting, difference of squares, right? You can kind of see it as you go, product sum, GCF, and then difference of squares. This is difference of squares, and GCF, and then difference of squares. So like as you go through them, you can think about tackling them these ways, right? And you'll also see some expanding, simplifying questions as well, factoring, solving by factoring, quadratic equation questions as well. And you see that right here. Okay, anything else? You guys should probably get to bed soon anyway. Got an exam tomorrow. Okay, so just running through this, make sure you know all this stuff here. You'll see it. Quadratic word problems. There's 2 main types we did, motion and fencing. I'm sure you'll at least see one of each. All of these characteristics of the quadratic will show up. Sketching will show up. Vertex, all these sorts of things. This is more textbook questions. I think I assigned these for some extra practice, but I think they will be useful to go through. Centers of triangles, again, was not a big portion of the exam, but you will see your midpoint, your distance. I'm sure those are on there. We talked about how to find the equation of a line, and that's in your review as well. Equation of a line from points. Horizontal shift and vertical shift. That when you have your h and k values, this is your horizontal shift, that's your vertical shift. So like we never, like if I give you a vertice of 3 and 4, this is a vertical shift 3 units to the right, 4 units down. It just means like if you go to plot something, you're going 3 over 4 up, right? 3 over 4 up. That's all. 3D on the sheet. Oh, on the centers of triangles? I don't know what 3D. So yeah. Take a look at this, skim through these, make sure you know the multiple choice questions. This is our old test. These multiple choice questions are from the old test, so if you want the answers, they're just right in the multiple choice questions that we had gone through, so that should be fine. Preliminary stuff, you'll see this as multiple choice questions on the exam, so be aware of doing all of that. Systems of equations, be able to solve using substitution, elimination, and take a look at the word problems that we've kind of talked about. Also, types of solutions will be helpful. As we talked about, that'll be on the, probably, types of solutions is multiple choice questions. iPad Pro Part 2, Quadratics Part 2, 3D. Okay. Quadratics Part 2, 3D. Sure. So quadratics Part 2, 3D, the first thing you want to do is, if I were to solve this question, I would get rid of the fractions. So you have to multiply across by 6. So if I multiply across by 6, you're going to get 3x squared equals, when I multiply across by 6, keep in mind, like I'd put a 6 here, so 6 divided by 2 is 3. That's where I got that from. I put a 6 here, so 6 divided by 3 is 2. This becomes 2 4x minus 3. And then everyone always forgets to multiply this by 6, but you got to multiply this by 6 as well. And I bet if you did that, iPad Pro, that would be your mistake. So now I have 3x squared equals 8x plus 30. And I end up getting here 3x squared minus 8x minus 30 equals 0. Right, so this question says solve using the quadratic equation. So go right to the quadratic equation. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a. And x is 8 plus or minus 64 plus 6 times 30, 180 over 6. So I'm getting 8 plus or minus the square root of, that's going to be what, 244 over 6. And we would just leave it here. But like you can take more out, like you can clean this up, but it's fine to leave it like this for grade 10. It's fine for us. In grade 11, you do reducing radicals, and then you're expected to kind of break this down a bit more. Ferris wheel question for trig, no, just do the questions that I assigned in the worksheet here. You see right at the end, this is posted for you guys. Right here, the stuff we did, take a look at the test questions as well. And you should be fine. Like non-Ferris wheel. But there's D. No problem, no problem. All right. Well, I guess that's it for us. Good luck tomorrow, everyone. Get your sleep. But I think we're all right. This stream will post, and you guys can rewatch it if you like. If there's any like things you want to check out. If there's any specific issues you're having, you can go back to some of the videos we had done. That sort of thing. But just make sure that you're good on quadratics and trig. Like we had talked about, that's the bulk of the course, of the, the course and the exam. I had outlined it. It's in the outline. You can check it out. But be good with that. Be good with your factoring, finding roots, quadratic equation, and all this work we're doing with the vertex, axis of symmetry, and all the different ways to find it. Make sure you're good with all of that. Okay, other than that, I will see you guys tomorrow. Oh yes, Diva. Yep, you too. You too. See ya, Dia. Keep in touch, Dia. Good luck on your exams. All right. See everyone.